Okay, so welcome to this video. This video is going to be dealing with motors and the power supply. And also we have an encoder here. So the motor that's centrally located is a hobby motor. So it's not geared. And it typically does run on a gearbox. So the one above it is a geared motor. And if you kind of take a look at this aspect of it, that is going to be what this looks like from a different angle. This is a power supply, and you can control the amperage and you can control the voltage. So up until now we've been using batteries. So batteries typically will use chemical energy to provide a voltage for a circuit, and we've got a whole bunch of different examples of that. The only one that the solar panel uses light from the sun to create energy, but the other ones are chemically formed. Now this one is actually something you plug into the wall, and it would adjust how much voltage. So if you can, I guess I'll zoom in here. So it's from 0 to 30 volts, and it's somewhere set in the middle of it, so that'd be like 15 volts. And on the bottom, amperage is from 0 to 5 amps. So I'm going to hit simulate, and we're going to take a look at what's happening. So the top motor is not working at all, and that's because I've put this switch in the circuit so that I can turn it on and on. The RPM is close to 30,000 RPM, so it's going really, really fast. And when we start using this top one here, you'll see that, well, I'll show you, it's only 500 RPM. And RPM means revolutions per minute. So if you sat there and counted for a minute, that's how many times it would go around. 30,000 is a ridiculous amount. Like, you would not be able to see it. This here is not indicating how fast it's going. It's just showing that it's moving. So if I was to slow down it by dropping the voltage, so that's only 4 volts, and now it's going about 8,000 RPMs. And if I was to press this button, it's only going 130 RPMs. So now I could do the opposite. I could increase it. I can max it out. So now it's going as fast as it'll go on 30 volts. And this is around 60,000 RPMs. I don't think that a motor like this would actually go that fast, but it's just an indication of its voltage. And now it's 1,000 RPM for our geared motor. You'll notice that the amperage stays pretty consistent. If I decrease the voltage, you're going to have it drop. And if I hit this switch, it spikes the amperage. Okay, so as long as the value here, so this is 81 milliamps, it's not even an amp yet. When I press the button, it's still only a third of an amp, so you think it has to get to 1,000 before it's a full amp. And if I increase the voltage and then hit the button, there, it's getting very close to an amp at that point. And I probably could get it to go over an amp if I max it out. And so now it is 1.87 amps. So it makes a big difference running this top motor in parallel with it. Okay, so the things that I want you to know is that there is such a device as called a geared motor, and the gear is to drop the RPM. So this normally is turning at 60,000 RPMs. When you press the button, it's only 1,000 RPMs. Okay, the other thing I want you to be realizing is that voltage affects how fast a motor goes. It also affects how powerful the motor is, and it also affects how long or short-lived that motor is. So when we drive a motor hard, it's going to shorten its life. The other thing is this servo motor. Let's stop the simulation for a second. This servo motor we're going to get to. We're not going to get to it now because it's got a signal, and it's got power, and it's got ground. The signal is going to have to be supplied by a microcontroller because it's a pulse. And this encoder is essentially something that you'd put on a motor so that you could tell what position it's in. So if you're making a robot arm, you're going to need an encoder to tell you where it is unless you're using a step motor. And we don't have a step motor here, so just a basic introduction. So what I want you to do is I want you to duplicate this. You can have it so that maybe you can rig it up so that it will go backwards. If I switch these leads over, I'll delete them. And I'll show you how I drew them in the first place. So if I go negative to positive, and positive to negative. Oh, by the way, when you guys are making your examples, try to make it pretty. Remember that number 1 is black. Okay, so now if I put the simulation on, what's going to happen? So there's a negative sign in front of the motor. So now what happens when I press this? There's also a negative sign. So reversing the polarity on the power supply will get the motor to turn in a reverse direction. And we're going to do some extensive videos on that, so you don't have to worry about that right now. Anyways, try to duplicate this. If you want to play with the switches so that it'll go in a different direction when you press the buttons, then you can try that. I will show you that later on so you don't have to. So anyways, good luck, have fun.